students. Today we shall be discussing about a new chapter, and the name of the new chapter is Walk. I'm going to begin with this new chapter here. Normally speaking, in our daily life, we do a lot of activities. If I write down some of the activities, like there are so many different kind of activities we normally used to do in our life. But if I just write down maybe like 4 activities which we are quite familiar with in our daily life, like playing and running. Then we also do certain kind of activities like reading and writing also. Now, what is the difference between these kind of activities is that in the above 2 activities here, this and playing and running, these kind of activities like playing and running needs a lot of energy in that. Whereas if you look at reading and writing are those activities which needs energy, but they do not need that much amount of energy like we used to need in the case of playing and running. So I now be right here, high energy right? Okay, so there are so many different kind of activities which we can categorize into different parts here based on the needs of the energy here. Now the point is, we are talking about energy for any kind of activity, whether it's like playing or running, or it's like reading or writing, we need energy. Now, energy here. Energy. Now from where we are getting this energy? We are getting this energy from the food which we take. If, let's suppose imagine, if in our daily life, if we take less amount of energy, then we will find it very difficult to perform this kind of activities like playing and running here. Because these kind of activities need very high amount of energy there, right? So, normally the kind of energy which we need comes from the food. Now if you talk about the machines here, machines, what are the kind of machines which we see in our daily life? The most common example, fan, right? Fan. Now fan, if you look at fan here, it has like 4 kind of plates, and they just some amount of work. What they do, they provide us with the amount of cool air which we need. Understand? Now, over here also, what we should be asking is that from where this fan, let's suppose imagine this fan is doing some amount of work. We knew that. Now, how this fan is able to do work? Fan is able to do work because they are able to get some amount of energy from the electricity, which we used to call as electrical energy, right? Electrical energy here. Understand? So in short, what I was trying to say from the beginning of this point to that point here, what I'm trying to say, whenever there is an involvement of energy, there is some amount of work. Understand? So this work and energy is very much interrelated with each other. These two words here, work and energy. Because if you wanted to do one work, you always need energy. Because in the absence of energy, you won't be able to do any kind of work. Is that clear? So this is a very important point which you should be able to know, that work and energy, they are very much deeply interrelated with each other. Because in order to work, you need always an energy in that, right? Okay. Okay, now regarding the work, we do so many kind of work. For example, preparing for exam, you spent day and night studying your textbook, writing notes, studying your notes, referring internet. All of this, how you used to write in sentence? I worked really hard. You used to say, I worked really hard. Understand? So when we were preparing for exam, in our normal context, we used to say, I worked really hard. Right? In a similar way, we also take an example of a person who used to work in an office here. Right? Okay, a person working in an office, because normally when a person he works in an office, he must be having a laptop or a computer in front of himself on a table, and he is writing something else, and he is doing some amount of like his own work, collecting data and all of this. Now in these two cases, we used to normally say that we are doing some amount of work, but according to the scientific definition of work, they don't call this as work. Because according to scientific definition, they have another concept also, right? Okay, let's go for it. Yeah, so now before I speak about the scientific definition of work, there is also a case like this is a person and he is holding a block in his hand, but he is not moving, he is in stationary position like this. So in that case, all the three cases here, 1, 2 and 3, we never used to consider this as work in the case of scientific definition of work done there, right? Okay, now you must be thinking, now what is that work done? What is that work, right? Okay, let me just give you one example. Okay, now this person is climbing a stairs. Understand? This person is climbing a stairs. Now in that case, in normal context, we will say he is just climbing up a stairs. But in that case, what we used to say, there is a work done in that, right? And in the second kind of situation here, there is a small boy and he is pulling his own toy car. We used to consider this as a work done. Understand? And in the third case here, there is a person who is pushing a table. Now in all these three cases here, what we used to consider is that in all these three cases, we say there is a definition of work according to science. Now, what is the difference between 1, 2, 3 and 1, 2, 3 here? Can you find out? So let me just go for it. Okay. Now, according to scientific definition of work, what it says that it needs to satisfy 2 points here. Whenever we wanted to define any kind of work, it is very important that we find 2 important points in that. Number 1, force should be applied. So can you look at this person here? Do you see this person is applying force on this table? Yes, because he is pushing this table. Do you see this person is climbing up the stairs? When he is climbing up, do you see that he is using some amount of force in that? Yes. And this person is pulling this toy car here, the small boy, is he using some amount of force? Yes, definitely force should be applied. Okay? And even in the case of the previous one also, right? A person who is holding a block, he is also applying some force. Yes, that is also work. But it also has to satisfy the second important point also. That is, second important point is the object should be displaced. That means the object should be moving from one position to another position. Now in the case of the person who is holding a block in his hand, even though he is applying force, but do you see that particular object is moving from one position to another position? No. So that is why in the previous case we don't consider that as a work done. But in this case here, when he is applying force, this particular table is being displaced from that position to this position over here. It is going to move here. And even in the case of himself also, right, he is going to displace. And even in the case of that particular toy car, is being displaced from that position A to position B. So, whenever we are defining work, we always have to define work as the amount of force. How do we define work? Work is defined as the amount of force applied on an object which is being displaced to some extent. Is how we define as work done, which we can also write as W is equal to F into S. Is that clear? I will repeat once again. How do we define work done? Work done when a force is applied on an object which is being displaced to a certain point, we call this as work done. Is that clear? Okay. Okay. Now this particular work done can come in the form of positive, can become a positive also. This work done can also come in the form of negative also. Then this work done can also come in the form of 0 also. Now let us have a look. Right? Now we knew that work done is equal to F into S. So let us have a look at the positive kind of work done. Now suppose imagine a person is pushing. Try to have a look on this particular example here. This person is pushing this table, right? Okay. Now, if I say this particular person is pushing this table here, is he applying force? Yes. A person is pushing a table. Is he applying force? Yes. He is applying the force in which direction? that direction, right? He's applying the force in this direction here. Force. Now, if I apply the force in that direction, what about the table? In which direction the table will move? If I apply the force in that direction, do you think the table will move in this direction? No way, right? If I apply the force in this direction, the table is definitely going to move in that direction here. So, let us say the S is also going to move in this direction here. Now, what do you see? The force and the displacement both are moving in the same direction. Do you see that? Whenever we come across a certain kind of situation where the force and the displacement both are acting in the same direction, we call this as positive kind of work done there. Is that clear? Now, in the case of negative kind of work done, let's suppose say let's say this person is applying the force in this direction, right? But do we also know another kind of force called frictional force, friction force? Yes, the frictional force, the friction used to act always in the direction, right? I'm sorry, sorry, he will try to move displacement in that direction there. But if you look at this frictional force here, understand? This frictional force always acts opposite to the motion of the object. So in that case, what do you see is that these particular two things here, that is force and the displacement, they are acting in opposite direction there. Understand? I can also give you another kind of example here. Okay, so there is a slope here, and there is a slope here, and there is a person here who is trying to push. Okay, he is trying to push the force in this direction here, but this particular object is covering the displacement in this direction here. Do you see that? Whenever we come across a certain kind of situation where the force and the displacement act in opposite direction, we call this as work done as negative work done. Is that clear? So, in short, the best example is the frictional one. For example, if I am walking, I cover the displacement in that direction, but the frictional force is moving, pushing me to the opposite direction, which is why my shoe sole have wear and tear, which causes the decrease in the sole of my own shoes. Is that clear? So, the frictional force is a very good example of negative work done. Is that clear? Okay. Okay. So now coming on to the zero kind of work done. Zero work done. Zero kind of work done. I normally find two kind of situation here. Understand? The first situation here, there is a wall, and to this wall a person is applying force. Understand? Now, do you see that person is applying force to this wall? I'm applying force to the wall. Okay? When I apply force, yes, definitely I'm using some amount of force. But do you really think that I will be able to displace this particular object from one position to another? I won't be, because it's too big for me. Understand? So, I'm applying force, but displacement will not be there, because this ball is not going to move at all. Understand? Is that clear? So, in that case, the work done is always equal to 0. Why? Because work done is equal to F into S. F could be 15, could be 100, could be any kind of value. But displacement is always 0, so anything multiplied by 0 is 0 then. Understand? But there is also another kind of situation here. For example, let's say a person who is walking on a straight road. Understand? So, as you can see, his displacement is in that direction here. Understand? His displacement is in that direction here, because he is moving in this direction. But where he is applying force? He is applying force down there, on the ground, right? This person is applying force down on the ground, but he is moving in that direction. Do you see there is a formation of 90 degree here? Whenever there is a formation of 90 degree between force and displacement, work done is again 0. Why? You must be thinking why? Because you will come to know about this in class 10. There is a chapter called trigonometry. Through this you will come to know about this particular concept here. Understand? Okay. So now we understood something about work done, positive, negative and 0 done. But we also knew that work done is force into mass, right? As I have written before. What is the unit of force? Newton. And what is the unit of distance? Is meter. So Newton meter, it is the unit of the work done. Is that clear? And we can also write, or we can also write joule as the unit of work done. So this is just about the work done, and at the end of this particular chapter, I will try to spend some amount of time in trying to solve some problem regarding this particular work done. Right? Thank you very much, all of you.